SimVT is a new workflow tool in Oasys LS-DYNA version 21 that makes it easy to perform simulation versus test correlations. This is an essential step in the automotive virtual testing frameworks, but SimVT is a versatile tool which can be used to compare any two data sources.
This video is a quick start guide using SimVT to compare LS-DYNA simulation data against ISO MME test data according to the Euro NCAP virtual testing far side protocol. And in it, we'll see how we can check our performance against validation criteria 1.
So I've opened a fresh session of THIS, and
before I load in the results, I'm just going to point out that I've got this automotive assessments workflow data JSON file, and that contains metadata that labels my model results. So I'll open up the results here. And because I had Open Menu automatically selected on the Workflows window, it opened automatically for me. If I didn't have that selected, I could open it manually by clicking on the Workflows tool here. Then, because we had automotive assessments workflow data, we see the workflow for that, as well as SimVT defined. And SimVT will utilize the automotive assessments workflow data when we open it. I can close the Workflows window, which I don't need anymore. And I'm greeted with a correlation setup window. And this is how I set up my correlations and choose my correlation method and various other settings. Before I proceed, I'm going to import some ISO MME data. So what I'm looking for is a .chn file or a .mmi file if I'm using version 2 of ISO MME data. And we can see that that's been loaded in, and we've automatically matched some of these channels. Now, by default, the reference test is set to the last imported model, so T1, and simulations are whatever models I've got loaded in. That's because imported data is generally assumed to be test data. I can, of course, change that by changing the drop-down on the selection here, and then same for simulations, but note that I can't select a simulation that's already a reference test. And with multiple simulations, I can select them by holding down Shift. Okay, so now I want to select the protocol I'm using, and here I'm using the Euro NCAP Virtual Farside version 1 protocol. A window appears to tell me that various settings have been automatically configured for me. So the rating method has been set to this particular flavor of the ISO TS 18571, which is consistent with the correlation method used on the Euro NCAP server. Additionally, I'm told that all the curves are going to be regularized automatically to 10 kHz, as done by the server. And then some additional logic is figuring out that my test data and simulation data is for a left-hand drive vehicle. So I'm only shown the channels for left-hand drive vehicle, but I can change that using the radio button here. The validation criteria 1 has been set so that the color banding in the correlation table will show green for those that are above 0.5 and they fulfill the criterion, or red if they fail. And finally, this last paragraph is saying that there is a requirement that the simulation has run for long enough, and the cutoff is 1.2 times the time of maximum head excursion. And in order to evaluate that, I need to click on the max equals button. So I'll click OK and do that now. And we can see that thankfully the analysis has run for long enough. So the black curve here represents the head excursion, and it goes into the green zone, indicating that there's a pass. And then the time of maximum head excursion times by 1.2 has been automatically set as my maximum evaluation interval. If I failed here, this would indicate that I should rerun my simulation with a longer end time. Now I can select the channels I want to correlate, and by default the protocol channels are only shown, so these 51 channels are shown. In this case, I'm just going to select them all and then click on correlate. A progress bar will appear showing me the correlations being performed, and we can see them also updating on the table here with the rating values. And once this has been completed, the weighted rating, which is the sensor score, will also be updated, and that will be based on the X, Y, and Z components. So if I hover over them, I can see the various weightings that contribute to this value. Clicking on ratings expands that, and I can see more details of the ratings. And if I would like to correct any of the curves, I can click on the operations to do that. So let's plot all of the results here. So I can see that there's an issue with my first three curves here, and the magnitude of them seems to be very different between the test and the simulation. However, the phase seems to align. So this suggests to me that there's an issue with the scaling of the two curves. And since this is rotational velocity, the most likely culprit is that the test data is actually in degrees per second, whereas the simulation data will be in radians per second. So in order to correct that, I just need to type in the correction factor, which is pi over 180, and that is 0.017453. And when I enter that, I can see that the first curve has been corrected. So now let's address the second curve here. So I want to enter the same value, and I could copy and paste it, but I want to apply the same change also to the Z component. So if I turn off auto plot and then turn off all the plotting here, I can select just the curves I want to edit. And then if I press enter here, I can propagate the value that I'd already entered into the multiply y column for the first curve. And when I click plot, that will be recomputed. And now I can see that they match very nicely. And my weighting has also been updated. So we can turn on all the plots here again, and we can scroll down and see if we have any more issues. So here I've got an issue with the shoulder forces. So if I click on this button here, we can see it highlighted below, and the issue appears to be one of basically the sign convention being opposite. So I simply just need to correct the sign by entering -1. And I'm going to assume that's the case for all of these curves to start with. So what I can do is I can turn them all off, and then I'll click on the first one that's problematic, and then hold down Shift and click on the last one. We can see that they're all highlighted. And then when we click on plot, it will update the plots, and we can see all of them shown here. So now we can correct them using the same approach before, propagating down with -1 here. We click on plot, and they're all going to be updated for me. I'll finish off looking down the table, and I can see that they're all now green, and I don't see any other issues. So I'll just do a quick skim through all the pages. So I'll turn plot on again, and then I can minimize this and just have a look through all the pages and see that I'm happy with all of the plots. You can see there's a small difference here with the phase of the plots, but that's understandable if the data is coming from different sources. Now that I'm happy with my corrected curves, I can export the results to a CSV, and I can also save a SimVT settings file in order to restore my settings at a later date.
This quick start guide demonstrates a range of SimVT features that are relevant when using the tool to compare LS-DYNA model results with ISO-MME test data. In summary, I showed you how to load SimVT with a single LS-DYNA model, how you can import ISO-MME data into SimVT, how to change the selected reference test and simulations, how you can change the protocol to EuroNCAP Farside V1 and how this configures SimVT, how to plot the head excursion to determine if the simulation has run for long enough, and how to set the maximum evaluation interval based on 1.2 times the time of maximum head excursion, how to plot the corridor correlations for simulation versus test, how to identify sensors which fail to meet the EuroNCAP virtual testing validation criteria 1, how you can perform corrective operations to individual channels and multiple channels at once, how you can highlight the corridor graph for individual channels, how you can change the virtual page, how you can export the results to a CSV, and finally how to save a SimVT settings file from the correlation table window so that the session can be restored at a later date. Thanks for watching. I hope you found this video useful, and feel free to reach out to us with any questions, comments, and requests.